Hello, I'm David Brown. I'm delighted to welcome you to our latest Imperial Future Matters series on machine learning and AI opportunities. A word about Imperial. As many of you know, we're focused across four areas of the business, business, engineering, medicine, and indeed natural sciences. That's one way of organizing, but in many ways, it's what happens in between, which is often the most exciting after our research and teaching. It's around innovation, it's around the application of what we're exploring, it's around actually being involved with startups, and it's most certainly being very, very engaged with business. But we know that that problems are solved or opportunities addressed through the intersection and so of these various disciplines. So what you can see in front of you is in fact how we are also organized to address some of the defining and most important issues in society around a sustainable society, around a healthy society, around smart and indeed resilient. So many of the research and teaching initiatives are around each of these areas. Now, in every single one of these areas, AI and machine learning is absolutely critical. So there's an enormous amount of activity around the AI and machine learning. We've been at this for many years. So there's over 50 labs that in laboratories that in some shape or form are involved in AI and machine learning, 600 academics, multiple centers, an enormous amount of degree and PhD activity around this area. And perhaps one of the areas that's most exciting and suggests that we're on the right topics, many of our academics, including those joining us today, are involved in both industry and teaching in some of the most important companies of the world, and you can see some of them. But it's not just companies, it's working closely with government and the regulators. So let me introduce you to some of our speakers today. So first, Prag Sharma, who is at Citi. He's an academic, consultant, entrepreneur, and indeed banker. He leads the Treasury and Trade Services Emerging Technologies Group and deep expertise in data analytics, AI, machine learning, and most of all, putting research and new ideas into practice at scale in a hugely regulated and in many ways public environment. Giles Pavey has 30 years in data science. He's currently at Unilever Global Data Science Director, where he's involved in supply chain, manufacturing, consumer behavior, and indeed ethics and sustainability. Prior to that, after a spell in government and 18 years at dunnhumby, the legendary dunnhumby. He's also well involved in the academic area with Oxford and UCL. I would add that his comments today are in a personal capacity. So, but leading our discussion today will be Professor Deeph Chana, professor at Imperial College. Deeph leads our co-director of our Center for Financial Technology, which works very, very closely with Citi, co-director for our Institute for Security Science and Technology, and indeed works very closely with all sorts of organizations, including NATO. He's also leading on our upcoming program within executive education on cybersecurity, and is very involved with multiple executive education clients. So before I introduce Deeph, a couple of just a process area. We'll have some comments from Deeph, The panel will have some questions, but we'd really like those questions to be driven by you. So in the from the Zoom application, you'll see the Q&A area. Please ask some questions, and then we'll discuss them after some comments and discussion from the team. With that, over to you, Deeph.
Hi, good morning. Hopefully you can all see the presentation, David.
Yeah, looks good.
Great. Well, good afternoon, everybody. Thanks for the introduction, David. So today I'm going to talk just over a few slides before we get into a discussion with Prag and Giles. As David said, it's great to have them with us here today. And the topic, machine learning and AI, opportunities and challenges for corporates. So the first thing I'm going to do is go over a little bit what actually machine learning is and a little bit of the history of it. And we'll do a little bit of a 101 around exactly what machine learning entails. So for those of you who are very well versed in the area, treat it as a little bit of a revision, I suppose. And for those who aren't, hopefully this will help you to get up to speed with the topic so that you can engage in the discussion. As David said, please do post as many questions as you would like. We want to have a very interactive session with all of you this morning. So, history of the development of this technology, of this area. So really, we go back to about the 1950s when people were very interested in how human beings think, and also whether or not it was possible to get computers to start calculating and working in a similar way to the human mind. And that's really why there was this interest in sort of building artificial intelligence, and that's why the phrase really exists. And as we fast forward through the decades from the 50s, then in the 80s and in the 2000s, what we had was a development of certain techniques which kind of look like they're a promising pathway towards achieving this idea of an artificial intelligence. And so machine learning as a technique really started taking off. And after 2010, really with the advent of the internet and large amounts of data availability, deep learning techniques, which were a special technique of machine learning, have really revolutionized the possibility of what the technology can practically achieve in the real world. Up until this time, there was a little bit of a winter, you might say, in terms of people's kind of commitment or belief that machine learning could ever actually be used for practical purposes. And so the real massive evolution is over from 2010 onwards has been the realization of how much application can be gained from machine learning and AI techniques. Important to point out here that AI and machine learning are actually two separate things, although the two are often conflated. I will probably use machine learning and AI interchangeably during this talk, so forgive me for that, and we can maybe have a discussion afterwards about what the material differences are actually between the two. So what's so different about AI and machine learning? We've had computers for a long time. They do their job very well. What's so different about programming and creating programs from machine learning and AI? Well, traditionally, we program computers explicitly, and machine learning is a way of us programming computers implicitly. And I'll explain a little bit what I mean about that over the next few slides. Here you have a formula, speed equals distance over time. Hopefully you would all recognize that from some point during your educations. And with this formula, what we actually have here is a piece of physics. So the intelligence here and the learning has been supplied by human beings who, through a scientific process involving experiments, hypothesis, and testing, have derived and learned the relationship between these three things, speed, distance, and time, to create a formula. And what you can see in the middle of your screen is a little code snippet of then how we can code into a computer that formula with a distance value, time value, and the formula explicitly stated inside the code. What changes with machine learning is, if we look at a problem slightly different way, now the goal is not for a human being necessarily to learn that relationship, but for the machine to learn the relationship between those things. And what we do is we expose the machine to a large amount of information. In this case, let's say distance information, where all the D's here on the right-hand side are a whole string of distance information. And through exposure to this amount of data, the machine learns the relationship that we just showed previously. And this is why this whole process is termed machine learning. But it's very important to note here, and we'll come back to this in a minute, that if we employ this process for understanding the relationship, we don't have the formula anymore, right? We don't actually have that formula. The machine has learned the relationship, but we haven't actually derived a formula at the moment. And that will be important for a discussion we'll have later on. So machine learning, as I said previously, was kind of inspired a bit by how biological systems and biological brains work. So this is a quick overview of the inspiration behind it. So this is a diagram of a biological neuron. And what we could see with biological neurons is that this special cell on the left-hand side can take in inputs, signals, think of it as data. And when enough signal stimulates the left-hand side, a signal is fired across the cell, leading to another signal being generated on the right-hand side. So you see there's this kind of threshold over which this cell actually fires off a signal in response to its inputs. And if we arrange lots of these cells together in a network, we can actually end up with a situation where information and signals can propagate through this network along different pathways, okay? And that is effectively a biological neural network, or network of neurons. So in software, the thinking was, well, how can we emulate some of that? So this is a diagram really of I guess, a software component, is the best way to think about it, where we take a bunch of inputs on the left-hand side, data inputs, I1, I2, I3, and they go into this circle. And in this circle, what we do is we kind of add that data up together, those signals together, those numbers together. And if they go over a certain threshold that we define, then we fire off an output on the right-hand side, analogous exactly to the function of the biological neuron. And extending this further, let's connect these artificial neurons together in a network, slightly more well arranged than the biological one. But what we now have is an artificial neural network. And what happens is this neural network we can use for computations in the same way as we did with a biological brain, where it takes inputs on the left-hand side and then produces outputs on the right-hand side. And of course, seeing as we're dealing with computers and software here, those inputs will be numbers, and as would be the outputs. So it can be sometimes a bit challenging for people to understand how everything can be represented as numbers, and in particular when we talk about images and videos and that kind of stuff. So let's look at an example of putting input into something like this neural net. So we can represent images as numbers in mathematical objects called matrices, and this makes that image ready for computing. So on the right-hand side here, we have the letter A. You can see that I can put a grid over the letter A, and I can turn that grid white or black, whether or not to represent the A, sorry. And that white and black grid, I can actually convert into zeros and ones. And now we have a data object of zeros and ones, which is a digital representation of the image, which we can use for image processing and as an input to our neural net. In this case, this is a black and white image, so we only need two numbers, 0 and 1, and this is what we call a binary encoding. We can use the same encoding to represent a wider range of numbers, and that can generate a wider range of colors. So when these numbers are then displayed onto a screen, we do a job of interpreting the numbers as colors, and that's the reason why we're able to then display images from numerical matrices such as these. So now we've got those numbers from our image. We can feed them into our neural net as an input, and the outputs, as I said previously, will also be a matrix, which will be a series of numbers. So hopefully that gives you an idea of the basic functions of how we can get a neural network to perform computation. So let's talk about training a little bit, because this is at the core of neural nets. How do we then program this neural network? Because remember, I said it's programmed implicitly rather than explicitly. So what we do here is we train the neural net in a similar way that we might even train a human being. So in this example, we might have a neural net that we would like to recognize apples when it's displayed a series of images of fruit. So in this case, we show it an apple. In the training example, we show it an apple, and remember this would be a digital representation of the apple, and it might guess that this is actually a banana. And in the training process, a human being would then mark this as an incorrect guess. And then what happens is we modify the neural network. In fact, those gray interconnections between the red circles that you see are slightly modified in terms of how strongly they're connected to each other. And then we ask for another guess. And this time the network guesses an orange. We mark that incorrect. The connections are modified again in a process called backpropagation normally, and we ask for another guess. And we continue doing this and marking answers as being incorrect in the hope that this neural net will slowly converge to be able to understand what an apple looks like. And eventually the target is for it to guess an apple correctly, and we mark that as correct. Now, obviously this is a very small data set example that I'm showing, and we have to do that over very, very large data sets to ensure that this neural net can perform as efficiently as possible in all circumstances within which we would like it to operate. So that's a very, very quick run through of machine learning and AI. As I said, some big simplifications there in order for us to get through that in a few minutes. But hopefully now for everybody, it's clear what the ramifications and impact might be. Because from everything from time series data, such as we had in that speed equals distance over time example, to image processing, video processing, content generation, as we've shown with the simple image processing problem that I showed, we can see impact right across nearly every industry you can think of. So clearly in financial systems, the development of services and tools, and analysis. In medicine, huge potential there. And of course, with COVID-19, I think you're all well aware of the kind of developments that people can aim to achieve with data and machine learning technologies. Advanced manufacturing, development of autonomous vehicles and autonomous systems generally are dependent on machine learning and AI agents or programs operating at their core. And then, of course, we have everything from logistics, weapons and defense systems, content generation, that's gathering content and dissemination. And that particular one, content generation, I think is quite interesting because, of course, at the moment, what is a live news story is TikTok. And at the core of TikTok is the development of their machine learning engine, which is actually the core IP, which is I guess is up for grabs at the moment. And beyond those industrial sectors, we can also see that machine learning and AI has the potential to address some of the very big global challenges that we're facing as human beings. Challenges around protection of the environment, the development of medicine and health for all, the provision of energy across the globe, security and defense, as I mentioned earlier on, and generally just powering the data economy and enabling inclusion into the data economies of the future. These are all difficult, multidimensional data problems. And because they involve large amounts of data, they are very well suited to being solved by machine learning or addressed by machine learning and AI type programs. But it's very important to understand the potential of the technology and its limitations. And there are numerous myths and facts circulating at any one time about machine learning and AI. This is a slide showing an output from futurelife.org, which is a very interesting website where they explore these myths and facts in a bit more detail if you're interested. But if we just look at COVID-19, we can see that people's understanding of technology generally can be quite wide-ranging. And if you look at some of the conspiracy theories around the various technologies over the last few months, you can see that misunderstanding can cause quite a lot of problems. So there are some myths, as I said, and some facts, but one of the issues that we do need to concern ourselves with is that the goals of any of these AI agents and programs must be well stated, because it is a real risk that in some cases, the goals of the programs that we create may start to diverge from our own goals. And this is a serious concern when we're talking about mass adoption of automated and AI machine learning driven systems. Also, the route to the solution that an AI agent may take may not necessarily be the route that we would like it to take. So if you think of the case of autonomous vehicles, we need to make sure that when we ask an object like a robot or a vehicle to go from point A to point B, that it does so without harming anybody. Because of course, there are a load of solutions to that problem of going from A to B where you might harm people. So those kind of considerations have to be built into our implementations. And policymakers and other decision makers, I would contend right now, are really not as well equipped to understand the nuances of this technology as they need to be. And again, something we can explore in the discussion to come after this presentation. And I mentioned the difference between AI and machine learning. So machine learning really seems more methodological than the final goal, which is to achieve real machine intelligence, or super intelligence, as some people call it, a machine that is able effectively to think for itself. And it's likely that this goal is still some way away, maybe decades away. But it's very important, therefore, that we actually start to think about the ramifications of that realization, and issues such as the legal status of AI agents and machine learning agents need to be considered today. And these kind of considerations become very important today because we are already facing certain issues with machine learning and AI implementation. And I want to stress here that machine learning implementations, as we said, rely on data. And if you think about it, all data is history. And if there's nothing but history to direct our actions, then inherent bias in society will necessarily be reflected in the decisions that will be made by machine learning and AI systems. A good example has been the use of facial recognition for policing, which some of you would have seen in the news over the last few months. Several large companies have backed out of the use of machine learning for facial recognition for crime prevention, as the biases, there are inherent biases, racial biases in particular, which these systems display due to the biases in the data that they are fed. And we overcome these limitations, humans overcome these limitations in just learning from data by setting values and goals as our objectives, which are not necessarily borne out by the data. So achieving equality and diversity, achieving peace and equitable opportunity, achieving impartiality in legal systems and judgments, all of these are actually value statements and goals, which we know that if we inspect the data in many cases, our own data, our own history, the data tells us we are quite a distance from actually achieving these. So just relying on the data to tell us what we should do next is clearly something that we cannot emulate inside a machine learning and AI implementations. So it seems that AI, machine learning need to be driven by more than just data. They will need technology values and technology goals. And there are a few organizations already working towards that. The United Nations has a series of sustainable development goals for the world. And in 2027, they convened the AI for Good Global Summit, seeking an alignment between how AI and machine learning systems are developed and implemented with these development goals. And of course, when you start examining this, you see the massive gap that we have in actually getting anywhere near these goals at the moment. And it's an interesting question now to pose: what role will corporates play in being able to shape a world in which machine learning and AI is implemented, and shape the way in which that technology drives us towards such goals? If we look at governments, we can see that governments are already starting to think about regulation, but it's a very, very fractured kind of global view. This is a graph that was produced in 2019 by the Law Library of Congress in the US. And it just shows countries where there are strategies in place already, countries where other strategies being developed, and countries where there is no strategy at all. And you might then from this realize that the protection of data and citizens' information becomes well, you can see becomes very, very topical by regions around the world, and the strategies that are in place are actually very, very different. So if you look at the countries that do have strategies, you'll see quite different takes on how people are looking at creating policies and regulation, which of course will have huge impacts on exactly how businesses and industry will be able to use, deploy, and develop machine learning and AI systems. And there are other issues too. this is a video which you can see online. Some researchers at in Washington actually developed this deep fake of President Obama using something called a generative adversarial neural net to create a synthetic version of Barack Obama, which could be voiced over. And if you watch this, you'll find it's very, very difficult to see any difference between a video of the former president, a real video of the former president, and the fake. And this, of course, has huge ramifications for states being able to generate misinformation, disinformation, and not just for states, because the barrier to entry to this technology is lowering every day, and is something that is it's possible for people to use on their home computers now. We also have a very, very interconnected globe when it comes to technology. The red dots on this graph are actually results from a search engine called Shodan. So this was done a few years ago in my group, and we were looking at potential vulnerable computer systems around the world to cybersecurity attack. And this was a single search with a single set of parameters where we found all of these locations, these machines that would be extremely vulnerable. Using machine learning and AI then to attack such systems and to propagate those attacks around the world becomes a serious concern for everyone. So, last couple of slides. I just want to go back and talk about some of the things that we are now currently working on, or the issues and problems that people are considering with AI and machine learning. As I said before, when we first started the talk, machine learning, when we build an artificial neural net, we really don't understand how to, we can't fully explain how that machine learning agent or program arrived at its outputs or answers. Because if you remember, we don't have the formula anymore. That machine has actually learnt relationships. And it turns out it's very difficult for us to examine the state of the artificial neural network and to understand exactly how it takes inputs and maps them to outputs. This has huge implications now for such considerations as how we trust such systems. So if you can imagine an autonomous agent doing anything from maybe trading through to driving an autonomous vehicle, how can we measure trust and reliability of these systems? How can we make sure that they will behave the way that we think they should behave in edge conditions, in low probability, high impact scenarios, such as emergencies and crises? But also, the example I showed you was really a supervised learning process where a human being is kind of involved in the initial training. But in unsupervised or semi-supervised learning scenarios, machines will evolve through the data and their interactions that they have through their operation, thereby changing the very programming, their implicit programming. And again, how do we know that as they evolve, that their goals are orientated towards what we want them to achieve? And this has, obviously, as I said, big ramifications in terms of our ability and our confidence in implementing these systems in certain scenarios. Another problem associated to this is if we have a third party developing a technology, how can we understand and examine how that system has been built? It's very difficult for us to undertake due diligence. And trustworthiness becomes a big thing to think about. Can we trust the machines? Do we know actually what it means to trust each other first is motivated by the question, can we trust the machines? Do we have metrics to understand trust between human beings? It turns out that we don't. And so this is an intersection of where social science and the more quantitative sciences have to come together to try and address this issue. And so I just finished with a summary of some of these open issues. Auditing and understanding the decisions made by machines are things that we are currently investigating and trying to figure out. Ensuring that agents, the AI agents and programs take safe pathways to solve the problems is another open issue. Understanding generally what could go wrong with the technology and the severity of the potential impacts are security considerations that are obviously extremely important, particularly with the proliferation of technology around the globe. And then there are other things like the relationship between the citizen and the state that I alluded to earlier. And again, thinking about what happened with COVID-19 and the sort of public reaction to being able to give up data in order to power such technologies. there is a very live debate around the relationship that the citizens have with corporates, the state, and the protections that they have around their data. And then when we look at value systems, of course, we have to think about what will those values be, and more importantly, who is going to write those values down, and who will put those policies in place, and will they be regional, and will they be global? And this has massive implications, I would argue, for business seeking to use, adopt, and implement such technologies in the future. I'm going to stop there, and I will now move on to the discussion with our panelists. So Prag and Giles, I hope you can still hear me very well.
Hi, yeah, can you hear us?
Yes, I can hear you really well. I hope everyone else can too. So it seems that we already have some interesting debates going on in the audience, but I wanted to start off, both of you. I mean, again, as I said, it's great to have you here with us today. I kind of have gone over a little bit of the sort of theoretical underpinnings of all of this stuff, but I wondered if you could give me an example, Prag, or a few examples, and then maybe after that, Giles, yourself, of disruptions, AI and machine learning disruptions that you have seen and experienced directly to date.
Yeah, I mean, AI disruption, in one sense, it's everywhere, right? You feel it around you, it's happening. And then there's some stuff that's happening in the long term. So from a personal perspective, and currently I work in Citibank, and in there we have two separate areas where we can see AI making a big disruption, which is one in the engineering side of things. So engineering and plumbing that goes behind the scenes is completely being changed by the demands of AI. And by that, I mean, big data environments are now becoming the norm for processing data. We also need to look at sort of how we can expand further through cloud computing approaches. So from an engineering perspective, there has been multi-year projects and changes that are being driven by AI specifically because of its need to consume data. From a product or client perspective, the real disruption that's happening is that we need to personalize our engagement with our clients, and AI is solely driving that. So before you would develop a tool, and that tool would be used by our entire client base. But actually, machine learning is making it possible, and the demand is there to personalize that interaction or interface with our clients to make it that much more useful for them, thereby saving time in the short run, and which adds up to the long run. These things are really come under the heading of boring AI already, right? This is all boring AI stuff, because the sexy or the cooler stuff is what's happening around us as well. In terms of self-driving cars, for example, maybe there are likely to be drones in the near future, which are all being driven outside. So between the two of you, these are the sort of disruptions that I'm seeing from a work perspective, which is already being termed boring AI. As soon as I touch the internet, everything I do is being helped by AI, from my search engine to the results that I'm displayed to the interaction in the cyberspace. And then for the larger world around me, I'm starting to see AI make an impact, mainly in the transport space and so on.
Brilliant. Thanks, Prag. And Giles, what about yourself?
So everybody would appreciate the differences, the changes it's made to retail.
Yeah.
If you start with a digital business like Amazon, AI completely enables their business. You know, the website that any of us on this call see is personalized exactly to us. The only way they can do that is through running AI. The pricing, the logistics, the whole way it works. But that's also now happening in the bricks and mortar retail world. So any Tesco you go into, what's for sale in that will be as a result of AI calculations on what do the local community, what do they like, what would their best suit to have, what's the best way of giving them a choice so that everybody can find at least one product that they like. So anywhere where you see big data, you will see AI or machine learning, I guess, specifically, because big data and machine learning, there's no way to get anything out of big data without machine learning, and you can't do machine learning without big data. So they're completely symbiotic.
Yeah, and you know what, following on from that then, Giles, I touched upon this idea of people's understanding / misunderstanding of the technologies. From your perspective, Do you see that as an issue? I mean, I think there is an issue between the sort of kind of expectations around the technology that certain decision makers might have and the reality of what it can do today and tomorrow. And maybe if you could grab that, and then I'll move to Prag, because I know he'll want to say something about that.
Yeah, it really is quite amazing, and I think it lurches from side to side. So everybody has access to Google Search, which just appears to be magical. And if they set their expectation by Google Search, they're failing to spot that Google spend, I think it's $21 billion on research every year. No other organization is going to be able to create products that are as just magical as Google Search. But then I also see it the other way, where there are known kind of AI solutions to things like image recognition, and that will just absolutely astound chief executives or whatever, that these things can be done. So yeah, I think that I think chief executives and boards get it, and I think that they are pretty well read. I think probably it's more maybe middle management that where the education really has to would benefit everybody.
Thanks, Charles. Prag?
Yeah, I agree. An interesting example, Giles, of Google search, right? If you look at it today, if you take your phones out, I don't want to distract people from what they're listening to, but if you do that afterwards, take your phone out, type in not elephant in Google search, or not something, not an elephant, and look at images, it will show you pictures of elephants. This is despite them spending billions of dollars on searches and looking and sifting through images. The point I'm trying to make there is a long way to go for this to become what we think AI means. For a lot of people, for me, AI often brings images of R2-D2 for Star Wars fans, for example, or 3CPO if you're even thinking more intelligently. But really, we're not there yet. So that's one way to look at expectation. The other way to look at expectations is, yeah, it is meeting expectations for certain industries, for sure. Like Giles was saying, industries that are natively digital, their expectations are being met in terms of their entire businesses are digital. And they can use machine learning in so many different aspects of their business to generate revenue, to create new products and services for their clients, that their expectations are absolutely being met. But other industries look at those industries and think we can also do the same. But there is a gap. And that gap is the data that they hold and the data that we hold. Industries that are not natively digital, that require an effort to convert their data into digital format, have that journey to make before they get benefit of AI. This expectation is not often matched at the senior level, at middle levels, and sometimes at junior levels. So looking at the best in class from a machine learning perspective that have made money, Google, for example, Facebooks of this world, that are making money on digitally native, other organizations and parts of the businesses want to do the same, but there is a journey, and that data journey needs to be met.
Yeah, and do you think, what, just to follow on from that before we turn to the audience, maybe, do you think there's an issue around every problem needs AI these days? That's the default thing to go to, and we're not going to consider any kind of other technical solution. It's got to be an AI solution. I tend to see that even in academia quite often, but I just wondered if you could comment on that.
Especially deep neural nets, right? Because they are, look, it's okay to be fashionable, because being fashionable or having something to go for has benefits. The benefits of being fashionable, I try to be fashionable myself, even if you may not be able to tell that from the picture. But the idea is that being fashionable means that it is at the topmost level in any organization. That means it has got the dollars and the money behind it to start looking at it in more detail, and it is in the C-suite level. So being fashionable obviously has its advantages. That's the first point to make. The disadvantage of being fashionable or trying to crack every nut with the same tool is that it isn't suitable for every nut, right? And we really need to figure out where the most suitable applications of machine learning are. And some of the papers I was reading recently, the biggest gap nowadays is converting your problem or issue into a machine learning problem. Yeah. That gap is not so straightforward. That needs to be addressed properly. And I think that's where people sort of think differently and feel that they are, feel that AI is not delivering, or it needs to deliver in spaces where it's not capable of delivering. That would be my comment on it.
I agree. I think there needs to be a judicious use of the technology in the right place. Giles, maybe you could pick up for a very quick comment, and then I'll ask David if we've got some. Well, I suspect we do have questions, but we'll go to the audience for some questions. Then.
Yeah. One part of my job is that I'm often asked to come in and assess the merits of AI claims from vendors and whatever. And I came across a brilliant stat which came from a survey done by MMC Ventures, European startups, and they looked into, I think it was a couple of thousand startups claiming to have AI, and it was over 40% of them had no discernible AI in them at all.
Yeah.
It was just a sales pitch, and I say that as if it's the worst thing ever. But I have been known myself, if I've got a model which is maybe a simple regression, to use the wider definition of AI to say, oh yeah, we did some advanced analytics on this, and yeah, I guess the most important thing is that if you do work, you want it to be implemented, and if the naming, you have to be a bit loose in order to get great work implemented, then I for one will happily do that.
Well, Giles, I think yours is a minor transgression compared to the ones I've seen.
Yeah.
I mean, genuinely the same. I've done some due diligence on some startups and things over the years where there's nothing.
Yeah.
There's nothing recognizable in there as you call machine learning. But of course, it's powered by machine learning, and of course, that has a huge issue. That presents a huge issue to investors and people looking to back the right horses in this kind of in these kind of situations. David, could we move over to you, and could you just let me know what we have maybe from the audience?
Yeah, a lot of questions. But one of the areas is a lot of them revolve around this question of how do we know? Now that means that's at several different levels. But one of them, when we were describing the ability to learn and through the neural networks and so forth, which is what's good? How do we know what's good enough? So making a book suggestion that's not exactly right is probably, we could live with that. When you're driving at sort of 70 miles an hour on the motorway or even in town, that's rather more significant. So how do we know when we have is good enough and reliable enough?
That's a superb question. I might just quickly jump in there and then get the guys to comment as well. I mean, driverless cars is a fantastic example of that. And actually, is to do better than the original human operator, right? Okay, so if you look at things like machine learning and AI for autonomous vehicles, it's quite interesting in the early discussions around that. Where do you set the bar in terms of competence for that driver? And you might argue that just statistically doing better than human beings in road traffic accidents, for example, or fatalities, means that's a good replacement, right? However, it then turns out that there are certain types of accidents. So if it was just a numbers game in terms of how many fatalities we'd have on the roads, that would be maybe fairly straightforward. But it turns out that there are certain fatalities and certain scenarios and dilemmas within which we would like the machine to make different decisions. So there's this whole thing about, a car driving down the road, and maybe there's young people on the side of the road, there's a group of them, and then there's a car of slightly elderly people on the other, and it's about to crash into that car. What decision should it make at this point in time? Somebody's going to make, there will be a fatality. How do you then make a decision there and audit that later on to say that that was the correct decision to make? It's very complicated sort of thing. It's not just a numbers game. But Giles, maybe I'll come to you first.
Yeah, I mean that one part of this is that we don't know how humans make decisions. And there is absolutely reams of research that shows that as human in decision making, we are inconsistent. There's a famous case of analysis of what judges gave out as sentences and how that differed significantly before and after lunch. And to set computers with a different standard is therefore an interesting situation. But I think car driving is going to be amazing. I think what's going to happen with cars is that autonomous vehicles will only be let loose once they're about 100 times better than humans. And then, when road traffic deaths go down from 7 a day or whatever the UK average is at the moment to, less than 1, then I think, the argument will be done. and as a cyclist as well as a driver, you know, I'm looking forward to, hopefully in my lifetime, autonomous vehicles that, you know, do constantly stay aware and are constantly, you know, aren't distracted by anything else that's going on, you know, take to the road. But I think there's this, you know, we saw it all play out with the UK exam situation, where I think, to be fair, maybe the Ofqual algorithm wasn't necessarily strictly machine learning. I think it was more statistical, but to most intents and purposes, you can consider it to be AI. And just the you know, the results from that, when compared to the human decision making by teachers, you know, really sort of showed the situation we're currently at, which is, you know, the feeling that humans, even though can't necessarily explain why they did it, you know, humans are what we've known obviously all of our lives, and so there's a really big, you know, there's a big question here, there's a big hurdle, but I think that it's also a very interesting thing about shining a light onto human bias and inconsistency.
Brilliant, thanks, Giles. Prag, when's it good enough to deploy?
Yeah. The short answer is we don't necessarily know in all cases, right? It's impossible to know whether the results of a complex algorithm are good enough or not. Having said that, in some cases, like David was pointing out, we don't care. We don't necessarily need to know how it was done, but certainly the results need to make sense. It's not the end of the world if I got a wrong book recommended, for example, you know. So that's fine. But in cases where we do need to know, such as when it comes down to law enforcement and some famous cases around that, or like the judge's parole cases that you were just talking about, Giles, this affects individuals, or in the banking space, if there's loan arrangements to be made. When this affects individuals, we need to know. And the question there then comes down to, if we need to know, we need to understand how the decision was made. And this is your concept of a black box earlier. So in these scenarios, we really need to understand how this algorithm is working. Having made that point, though, it will be impossible to ever understand how these algorithms are working. We're already heading towards algorithms that are, in my opinion, a 1.6 billion parameter deep neural net, such as GPT-3. You will never, it doesn't matter what you come up with, you are unlikely to ever explain the inner workings of that.
Yeah.
So then the discussion goes to, okay, in that case, we actually need to have rules and regulations that support that, which is what Giles' point was earlier. We actually need to understand the rules and regulations, much like human beings, so that we can control what these machines are doing. And that's another way to know whether these are good enough. If we have regulations and legislation that says this is what good enough means in this scenario, then we have to meet those targets as opposed to understand what the machine is doing itself. So those are a couple of different angles. And one other point to make quickly is, today's machine learning, we're talking in today's concept, it's a really smart 6-year-old mathematician. You know, you can look at it that way. Some lad, he's 6, so he has my son has massive gaps in the world. He doesn't understand where money comes into my bank from, for example. But if he was a really smart mathematician, he could add and subtract and do all sorts of funky stuff. This is where we find ourselves. And this is what we're trying to legislate against, or trying to say. And when you were saying expectations, you have to set your expectations with a really smart 6-year-old, you know, that expectations need to be set.
I suspect he won't really be interested where the money comes from into your bank account for some time yet. Prag, yes. He'll continue at least feigning ignorance for a while. David,
where it goes out, that's what he's more interested in.
Yes.
There's a question here from Philip Howard and an anonymous person as well. So there's a couple of elements around this. You mentioned the Google no elephant, and then he's referring to Twitter as well, who just made some pretty horrendous errors on this. And Deeph, you mentioned in your presentation how, because they're so complex, some of the algorithms need to be driven by values. Others have touched on that. So whose values? Is this the Asimov 3 laws? Is this Zuckerberg's values? Is this Brin's values? Or God help us, Elon Musk values?
So David,
and given the amount of money that was also being mentioned in terms of some of the big players, then actually is money going to drive whose values we follow?
Right. So listen, I'll quickly take this. This is, for me personally, this is an enormously interesting issue and a core issue as well, right? So exactly right. We know, we can see already that we need a value-driven system, regulation, rules, policies, or whatever, right? That's how we work as human beings. As I said, an example, we're trying to eliminate racism in societies because we know we have it in the data. Right, so it's an extant problem, and so there's no data telling us we want to get rid of racism. It's an aspiration and a value that we want to drive towards, and similarly, we need that sort of values for technologies. The question then is, who is going to write those values, right? Or will we have global consensus around those values? And it really starts talking to these kind of, these global institutions and the idea of nations collaborating potentially in order to create these joint value systems, and whether or not we're able to do that. So ironically, I would say the technology starts asking very serious questions about humanity and about how well ordered and arranged we are versus how well and ordered we think we are, right? And it's interesting when you canvass, let's say, countries who belong to, kind of consortia and, clubs for whatever reason, there's no real consistency in the values that they have between them sometimes, or very often. And so I think this is a hugely important question. And then, of course, the final part of that is, how are corporations going to play into influencing these developments? Now, you see already big corporations having significant inputs to governmental policy making all around the world in these issues. How is that going to work? How exposed will citizens be to that process? Is it right? Is it wrong? Many different questions. Prag, maybe I'll go to you first on this and go to Giles.
Yeah, I think clearly any of our technology should reflect our values, but which values will they be reflected is interesting. In the European Union, we look at individuals as prime individual components, and that is what we really want to ensure, that each individual has values. That's not necessarily the case everywhere. In other countries, they look at society as a whole, and if it's delivering benefit to society as a whole, might overlook a few individual values. That's sometimes okay too. So there's lots of different value systems, and clearly our machine learning algorithms have to be developed with those in mind from the ground up, for sure. So that's where I would see it. The money question is interesting as well. Recent articles talked about it can cost several $1 million to have one training round of these large algorithms today. And this is, it costs Google the 25 million reportedly in hardware and other costs with DeepMind to train the AlphaGo system, for example. So there is a huge amount of money involved to get to the state of the art. Some of these state of the art systems are guiding some of where machine learning is heading, and inadvertently are taking us into a value system from that perspective as well.
Fascinating. Giles.
Yeah, a couple of examples from insurance. We have a value in Europe, which is that men and women shouldn't be charged differently for the same product. That has resulted in car insurance, where women are far less likely to make large insurance claims, being charged the same as men, or theoretically, which means that the model for how prices are set is not allowed to consider gender. However, it does consider occupation and what vehicle you have and where you live, all of which are correlated to your gender.
And age, I bet, as well, Giles.
Well, yeah, the same for age as well. And all of, so this is, I guess, an example of, well, firstly, do we want that women can't be pay less for their insurance, as a consequence of that blanket rule? But secondly, even if you put that rule in, the algorithm or the data will find a sort of a way around it if there is a signal there. But the second example is really that we have to think about how humans use the model. So if you apply for car insurance at Tesco, or it definitely used to be the case, you'll be given an option to put in your club card number, which will then open up the model to access on what groceries you've been buying. And it turns out that there's a signal within what groceries you've been buying and how regularly you go shopping and how many shops you go to, which will feed into how likely you are to make an insurance claim. The thing that Tesco decided to do is that signal might show that you're either more or less of a risk. If it shows that you're less of a risk, Tesco decided that they will offer you a lesser price. However, if that signal shows that you're more of a risk, Tesco will waive that price differential, and they'll actually just charge you the price as if you hadn't given that data. Mm-hmm. So that's where, in that case, they've made a decision to only, if you like, use the positive side of the algorithm outputs.
Yeah.
I think that this, how do humans and computers work together is certainly the way that we will solve most of these conundrums of being able to, if you like, have a prediction or a suggestion from the model, but then it's a human making a decision about how that then impacts somebody's life.
Brilliant, thanks, Giles. David, I'm conscious of time, and I know...
Let me just got one more question, which I perhaps ask you to address briefly. Andy Murray, I'm not sure it's a tennis player, but anyway, has referred to that it's that a lot of people say it's urgent, but others have no strategy and capability. So, a lot of big questions we posed today, and it's singularly clear that most companies don't have the capability. Clearly, this is close to our heart. But how do we develop capability in the numbers of people that are going to be required to execute the types of strategies we've been talking about? Briefly, if you wouldn't mind.
Yeah, okay. Well, maybe I'll start with one of you guys. Prag, any thoughts on that?
And so the question is around resources required, the skill set required to build out the machine learning landscape, is it? Is that
developing the resources, how we develop the capability?
Yeah, and I think probably, Prag, we're talking about developing, but understanding, decision-making around the implementation. It's a whole suite of different things, isn't it?
Yeah,
when you talk about the capability within a corporate.
Purely from a resource perspective, lots of universities nowadays are very much focusing on courses specifically around machine learning and AI. So there is a steady stream of maybe talent coming out of universities now that will fill up this space in the short term. But these are graduates coming out of college that understand how to code well and understand how the maths behind it. But then there is this whole aspect of understanding how to deploy these in large environments and all the other expertise that you don't get straight out of college, but get from experience. That gap will persist for a while until this new breed of researchers move up the ladder. So from my perspective, the gap is in the middle management to some degree. We have senior people who understand the business really well, who understand machine learning concepts really well. And then we have junior programmers who are coming straight out of college that can maybe help you code up this stuff really well. That shortage will finish. It's this middle ground that will continue to grow, where you can bridge the gap between senior management and junior developers and come up with use cases that will help push you through machine learning. That's one piece. The other piece, really quickly, from a gap in talent perspective, is not just that to really make machine learning important work in an organization, you need the data. And today, while we talk about zettabytes of data, that data is unevenly distributed. An IoT device today can release data every 6 seconds, but that's in countries where such IoT devices are available. What about data blank, such as some African countries, some other parts of the world where that data isn't generated, or organizations in those companies, and they are not able to sort of ride this wave of artificial intelligence that's coming down the line. So we also need to be mindful. We serve clients across the globe. We have to be mindful that we're serving our clients equally well, and machine learning cannot just be for certain clients that generate a lot of data. 100%
agree. Giles, just 30 seconds or so, if you could sorry to constrain you so much.
The irony is that, while it's so important, never has a skill been more open. So the MOOCs, the massive online open courses, if I've got that right, I've seen at every company I've worked at recently, just how many people are teaching themselves. Yeah. And I think that is where the answer lies. Also at UCL, we're now undertaking a program where we've put out a data science training for people in social sciences. So I think actually I'm optimistic. I think it is accessible. And I think most people would find that in their companies, there's probably 2, 3, 4 times as many people with an interest and an ability in data science as there are people with that job title.
Yeah.
To encourage them.
Brilliant. And David, I just quickly say, I think it's really about through life learning. And I think actually, it's just about just surfacing some of the detail of these technologies a little bit more to people. And I think making sure that people don't feel intimidated towards learning a little bit of that and going into greater depth. There's often quite a superficial understanding, I think, about these technologies, which people are a little bit hesitant to kind of explore further. Universities, I think, are a great place to, we're responsible to try and help push that mission forward. But David, I'm going to hand back over to you. Thanks you very much, Prag and Giles, for the conversation. David, over to you to wrap up then.
Great, thank you very much. Look, thank you for, firstly, thank you for just terrific comments. Giles, Prag, Deeph, really enjoyed it. There's hours more to go on this conversation. The gap is in the middle management, and it's about us to own our own learning. At Imperial, we can help a little bit with that. We've got a AI and machine learning in financial services course coming up in a few days' time. Deeph is leading a course on cyber with a strong AI component coming up in a few weeks. So see what I think we can help. And lastly, I would say thank you, and I would also say next Imperial Future Matters webinar is coming up on 21st of October, where we've got Professor Carol Proper, who is one of the world's leading economists, president of the Royal Economic Society, and Nelson Phillips, and it's going to be who is deeply involved in organizational design and leadership, and they'll be exploring organizational structure in terms of responding to the health crisis. Should be absolutely fascinating. So with a few seconds to go, thank you again to you, thank you again to our speakers, and look forward to seeing you on the 21st. Thank you.
Thank you.
Thanks a lot, everyone. Bye-bye.